Hello ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we're going over section 7.5, Rational Exponents. Now up to this point we've been adding and multiplying and dividing powers, exponents with powers. But now we're going to start going into some weird things. Now the weird things are what happens if we don't have a whole number for our exponent. Now we've been looking at something like 1/3 raised to the negative second. We know to turn this into 3 over 1 squared, which is 3 squared over 1 squared, which is 9 over 1, which is 9. We know how to do those. We know how to work with them. But if you'll note, the power is a whole number. Not all powers are whole numbers. Sometimes we have fractions for powers. And today we're going to go over what that fraction means. Okay, so here we go. Let's say that we have a basic number. Let's call it 4. Say hi, 4. Alright, that's enough out of you. Of course, it always makes them cry when they do that. I don't know why. Anyway, so we have a weeping 4, and we're going to say to number 4, hey, I want you to be raised to the 1/2 power. Now, what does that 1/2 mean? Well, in math land, the power represents how many times that you multiply it together. So what does a 1/2 really mean? It honestly means it's how or what number multiplied by itself two times gives me 4. In other words, it's a radical. We're looking at what is the square root of 4. What number multiplied by itself that many times, in this case 2, gives me my base. So what number multiplied by itself 2 times gives me 4? Well, that would be 2, because 2 times 2 is equal to 4, so the square root of 4 is equal to 2. What about something raised to the 1/3 power? Let's say that we have 8 being raised to the 1/3 power. How would we deal with that? Well, again, it's the same principle. We ask ourselves, what number multiplied by itself that many times gives me my base? So I'm going to write that down. What number multiplied by itself three times gives me 8. Or, what is the cubed root of 8? This 3 here tells me how many times I have to multiply a number by to get the number on the inside. So in this case, what number multiplied by itself 3 times gives me 8? Well, once again, we kind of luck out, because 2 times 2 times 2 is equal to 8. So the cubed root of 8 happens to be 2. So this is rather confusing. It is a little bit of new notation, but we need to get it down because this is a very powerful tool that allows us to plug into our calculators and find roots other than just the plain old square root. Because plain old square root, no offense to you, Mr. Square, but you're kind of boring. That's probably why they're called squares. So if I see something like the 5th root of a number, let's call it 125. To turn this into an exponent, I take this number here. This number is called the index. I take the index and I take my base and I raise it to 1 over the index in power. So in this case, the fifth root of 125 becomes 125 to the 1/5 power. I can then plug that into my calculator as 125 caret, open parentheses, 1 divided by 5, close parentheses. And when I do that with my handy dandy calculator, I get some number. Feel free to figure out the number on your own. Anybody get it? Nope. All right, well, I'll pull out my handy dandy calculator. So I go 125 caret 1 over 5, close, enter, and I get 2.63. All right. So yes, this can be really confusing, especially when we start doing some weird stuff with our exponents. But it does allow us to find multiple roots of any number. For example, what is the cubed root? Excuse me, my pen decided not to write that correctly. What is the cubed root of 125? Well, that's 125 to the 1/3 power, which is 125 caret 1 divided by 3, which is, surprisingly, 5. Okay, I'm not sure how many more examples that I can give or what better ways to explain this other than it's really basic arithmetic. You take the index, you put it on the denominator. If you have a power raised to a non-1 over something fraction, though, it does get a little different. For example, what is 4 to the 3/4 power? Sorry, let's make that 16. What is 16 raised to the 3/4 power? Well, here I'm going to actually use some of the principles that are some of the properties of multiplication that we've been working with before. I'm going to turn that 16 to the 3/4 into 16 to the 16 to the 1/4 raised to the 3rd. Now, this is the same thing as 1/4 times 3, which we know turns into 3/4. So I'm not really changing the value. I'm just changing the order in which I do things. And it will make my life a little bit easier, because I know that 16 to the 1/4 from my calculator is 2. And then 2 to the 3rd is 8. So 16 to the 3/4 is 8. It does make my life a little bit easier to try to break it apart like that, especially if it's numbers that I already know the roots to. For example, if I had 4 to the 5/2, well, I can turn this into 4 to the 1/2 raised to the 5th. 4 to the 1/2 is the square root of 4 raised to the 5th. And what's the square root of 4? You guessed it, 2. And then 2 to the 5th is pretty easy to do in your head. 2, 4, 8, 16, 32. This is going to be 32. So being able to manipulate these, being able to turn them into fractions and then roots or roots to fractions, helps tremendously when you're trying to figure numbers out, especially when your numbers are very complicated or convoluted, or, well, fractions, because gotta love fractions. Fractions are friends. All right, which leads us to our next concept. What happens if I take the cubed root of x to the 9th, y to the 3rd? Well, the first thing that I would want to do is get rid of the radical. I don't know about you guys, but after having spent some time in Iraq and Iran and all those other wonderful places, I have to say I really don't like radicals that much. They tend to do weird things, like strap bombs to things and blow them up just because it looks cool. I don't like radicals. So the first thing I'm going to do, get rid of them. Alright, radical, I'm going to turn you into x to the 9th, y to the 3rd, all raised to the 1 over 3 power. Now, from previously, we know from our tier system, from exponents, we go to multiplication. From multiplication, we go to addition. And from addition, we do nothing. So, this is an exponent, right? It's all being raised to the 1/3. So when am I going to do the exponents? Multiply them. So this becomes x to the 9 times 1/3, y to the 3 times 1/3. And we know how to multiply fractions by whole numbers. You divide by the bottom, multiply by the top. 9 divided by 3 is 3, times 1 is 3. So now I have x to the 3rd. And then 3 divided by 3 is 1, times 1 is 1, so I have y to the 1st. So what did that actually do? It looks like we just divided the power by the index. Remember, this is the index. Index. And this thing is called a radical, because it's pretty radical. So you take the index and you divide all the powers by the index. That should be easy to remember. Let's try it out. Let's say that I have x to the 12th, y to the 32nd over z to the 16th. And I am taking the 4th root of this beautiful fraction. What do I do the exponents? Oh yeah, we divide. What number do we divide by? 4. So I go 12 divided by 4 is, of course, 3, so I have x to the 3rd. 32 divided by 4 is 8, so I have y to the 8th. And then 16 divided by 4 is 4, so I have z to the 4th. Pretty easy? Pretty easy. Just remember to do them one piece at a time. Alright. When it comes to arithmetic, which this is basically arithmetic, very fancy arithmetic, but it's still arithmetic. When it comes to that, the best way to get it down is to practice and get help. So, practice time. It's bug work. Before you go, here's your bug work. This is going to be section 7.5. Hashtags. Radicals are in math. Beware the math radicals. Let's go 1 through 29 odd. And then 33, 37, 41, 45, 49, 51, keep going, 53, 55, 57, 59, let's go with 61, 65, 67, 71, 75, and 79. And of course we need word problems, so 83. I know it looks like a lot, but again, this stuff should be really quick and easy. Most of you should be done by the time class is over. Alright, that's it. Good luck and have fun.